Okay, so let's take a look at the formula that governs simple interest. The formula is I, that's a capital I, equals PRT, and the P is also capital. So what does the I stand for? The I stands for the actual interest that you earn, and that's in dollars. The P stands for the principal. It's also in dollars. The principal is how much money you invest or how much money you put into an account. The lowercase r stands for the interest rate, and it's always an annual interest rate. And the term used is derived from Latin, per annum. Annum is the same root as annual, so per annum is often abbreviated as PA. So it's always an annual interest rate, and you can express it either as a percentage or a decimal, but probably when you enter it into the calculator, you're going to use a decimal. You may have a calculator that has a percent key that helps you out there. If you want to use that, that's fine. And the T is time, and that again is always in years. Now we're going to see that we have to be a little bit inventive when it comes to actually dealing with time, because sometimes we will want to know interest over different periods like months or weeks or days, and so we'll spend some time learning how to convert those. You'll also have to know for some specific questions that ask you about calculating interest over specific dates, you're going to need to know how many days are in each month. And if you're given the year, you can also determine whether it's a leap year, and that makes a difference for February. If February is not in the span of time, then you don't need to worry about it. So I've got the list right there. January is 31, February is either 28 or 29, depending on whether it's a leap year. March is 31, April's 30, May is 31, June is 30, July and August are both 31, September is 30, October is 31, November is 30, and December is 31. So you're probably not going to see too many problems where they ask you to calculate interest over a certain number of months, because months are not all the same length. And so you would probably want to know, well, which months are we talking about? However, if it is just sort of a general question, you can convert months to years just by dividing by 12. So for instance, if they say 6 months, let's get it out of the rainbow here. If they say 6 months, all right, 6 months, well, how much is that in terms of years? It's just 6 over 12 years. And you could write that as a half a year or 0.5 years, right? What about weeks? Well, weeks are all the same, so that's good. There's 7 days in a week, but you have to be a little bit careful because a lot of people know that there are 52 weeks in a year. The problem is there aren't exactly 52 weeks in a year. So 52 weeks is actually 52 times 7, which is 364 days. So it's not quite a year. And for that reason, if you are going to convert from weeks into some fraction of years, the best idea is to convert it into days first. So days, are not going to be problematic. So for instance, if you want to convert 180 days into a certain number of years, you can just say, well, that's 180 over 365. It's about a half a year. And so, how much is that? Well, we're going to see a little later on when we do these calculations that you probably don't want or need to actually figure out what that is in terms of a decimal. It's going to be approximate. And so you're going to either have to write down an awful lot of decimal places to get accuracy, or if you round, you're going to be off, and you could be off by quite a bit. So it's actually better just to leave it as 180 over 365 and then punch that into the calculator and let the calculator take care of the accuracy. Okay, so let's take a look at a couple of problems. So here's, well, first off, what is simple interest and why is it simple? The idea behind simple interest is that you invest a certain amount of money, the principal, and then you get paid interest either when you terminate the investment, so if you just maybe invest your money for 90 days, for instance, at the end of the 90 days, you'll get paid interest. Or if it's a long-term investment, you'll get paid every year. But the money you get is just in the form of like a check. You can do whatever you like with it, but it doesn't continue to earn interest. So this is actually unlike a savings account, and it's unlike a lot of forms of investment. However, there's a very common and popular investment that does work this way, and it's known as Canada Savings Bonds. And so let's just take a look at a picture of an old Canada Savings Bond here. So here we have an old Canada Savings Bond, and they actually, it was like a large printed piece of paper, like a very large banknote, and it came with these coupons on the right hand side. Now these coupons were your sort of claim on interest. So you can see this is a $50 bond, so it cost $50 to buy this, and you can see that starting in 1962, and then again in 1963 and 64 and 65, all the way up to 1971, you would turn it in and collect interest. Now, the interest here actually varies from year to year. The first year is actually only $2.13. Most of these are $2.25, and then we get a couple up here that are $2.50. Now, $2.50 represents 5%. So this would be a 5%, for the most part, Canada Savings Bond, right? 10% of 50 is $5, and so half of that is $2.50. So that'd be 5%. And you would literally take this little coupon into the bank, and then you would get your $2.50, and you could do whatever you want with it. But it's not going to change how much interest you get the following year. Okay, so that's the idea behind a simple interest. So let's go back and do some problems. So just imagine we have a principal of $5,000 and an interest rate of 5%. And I don't have to say per annum or PA or anything like that. Anytime an interest rate is quoted, it's always annual, regardless of the time period we're talking about. And the time in this case, let's say, is 3 years. All right, so I is equal to P. I should make a capital P RT. So what is the P in this case? It's 5,000. What is the R? It's 5%. So you can leave it as 5% if you have a calculator that has a percent key. Otherwise, you're going to want to convert it to 0.05. And the time is 3. Now, I actually just want to do that first part, the first calculation, 5,000 times 0.05 first. If I do that, I get 250. So that actually represents the interest you would get every year. All right, 10%. It's always a good idea to estimate these things. 10% of 5,000 would be 500. 5% would therefore be half that, $250. So you'd be getting $250 every year, and since it lasts 3 years, you'd get a total of $750. All right, so the interest earned there is $750, and we can also say it's $250 per year over the course of 3 years. Okay, let's try another one, this time with numbers that are not quite so nice. What's the interest if the principal is $2,500 and the rate is 6.2%? And we're going to do this for 140 days. Okay, so again, we can estimate this just to get a ballpark idea, and that's a very good idea because it is so easy to punch something in incorrectly in your calculator and get some number that is nowhere near close. So again, this is the way I do it. $2,500, 10% would be 250. We're just moving the decimal place over 1 or chopping off a 0, whatever way you want to think about it. So $250, that would be at 10% for a full year. So 6.2% is going to be something less than $250, but not half. Half would be $125. So maybe we're looking at $150. Now, 140 days, though, that's quite a bit less than a half a year. So we're looking at less than 150 and quite a bit less than half of $150. So half of 150 would be 75. So maybe we're looking at $50 or $60. Okay, so if we get something in that ballpark, we know we're probably okay. So again, I is equal to PRT, and the P in this case is 2,500. The R is 0.062. And the time, here's where you want to write the time in years. So what is 140 days represented in years? It's 140 over 365. Okay, so if we, again, if we do the first two, we can see that the actual interest per year at 6.2% would be $155. My estimate was 150. And then we still need to multiply that by 140 over 365. And we get $59.45. All right, so we should probably just add the dollar sign there at the end. So $59.45. That's pretty close to our ballpark. Now, it wasn't exactly $59.45. So if we're talking about money and you're doing a calculation, you should round that to the nearest penny, but you should indicate that you've rounded it by putting a little dot over the equal sign. So it's approximate, but 59.45. All right, and you can just round that to the nearest penny. Okay, it's not always the case that we're going to be trying to calculate the interest given the other three. Sometimes we're going to be looking for one of the other three variables, but we need to know all the other information. So let's say we want to know what the principal is to generate a certain interest payment with a given interest rate and a given time. So we need to manipulate this equation, I equals P RT, and we need to solve it for P. We need to isolate for P. So the way we do that is divide both sides by R and divide both sides by T. So we get P is equal to the interest divided by RT. All right, so let's say for 3, let's say we want to know how much principal do we need to invest in order to get an interest payment of $1,000 given an interest rate of 4%, and we'll make life easy and just say 1 year. Okay, so we can kind of estimate this, right? I mean, if we invest $1,000 at 4% for a year, we're going to make $40 worth of interest. So to make $1,000 worth of interest, we're going to have to multiply that by 25 to get $1,000 worth of interest. So we're going to need to invest $25,000, and let's just double check that that works out. The principal, following the formula that I just worked out above, is interest divided by RT. So the R in this case is 0.04, and the T is 1. I don't really need to put it in there, but I'll put it in there. And when you punch that into your calculator, you should get $25,000. So indeed, $25,000 is what you're going to need to invest if you want to earn an interest payment of $1,000 at 4% over just a single year. Let's do one now exactly the same, but with numbers that aren't quite as friendly. Let's say that we are, again, looking for the principal, how much we need to invest. This time, we'd like to get an interest payment of $500, and we have an interest rate of 2.3%. And the time in this case is quite short. It's only 90 days. Okay, so again, let's do a little bit of estimation here. 2.3%, that's a lower interest rate. So if you invest $1,000 at 2.3%, 10% gives you 100, 2.3% gives you $23. All right. So we would need certainly 20 times that to get $500. So that would be $20,000. But we're not actually investing for a whole year. We're only investing for 90 days, which is a quarter of a year. So we need to ramp that up again by a factor of 4. So we're looking at something in the ballpark of $80,000, maybe a little more than $80,000. So let's just see if that's how it works out. We get the principal is equal to I over 0.023, And again, here, to save yourself from figuring out what 90 over 365 is and writing down some long decimals, just write it in as 90 over 365. Okay, but here you're going to have to practice this a few times if you're not familiar with doing this sort of calculation on your calculator, because time and time again I see students make mistakes here. So depending on the type of calculator you're using, you're probably going to want to use lots of brackets. So you're going to do 500 divided by, and then in brackets, 0.023 times 90 divided by 365, and then you close the bracket. If you don't put that product in the denominator in brackets, you'll end up not getting the answer that you want. In fact, instead of dividing by 90 over 365, you'll do the reverse of that. You'll actually multiply by 90 over 365, and so you'll get something that in this case will be off by a factor of about 16, so you'll probably get something around $5,000. And this does indeed come out to $88,164.25. Okay, and again, we've rounded that to the nearest penny. Okay, all right, so that's finding the principal. So obviously there's two other variables that we could possibly find, the rate and the time. Let's do a couple of questions involving finding the rate. We'd like to know the rate. In this case, let's imagine that the interest payment is $200. The principal is $1,000. And the time is 4 years. Okay, so these are both in dollars. So again, let's just do a little rough estimate here. $200 is 20% of $1,000. So if we were talking about just 1 year, we'd need 20% interest. Since we're talking about 4 years, it's going to be 1/4 of that. So instead of 20%, it's going to be 5%. All right. Now, the numbers are really nice here. You work out really easily, but you should be able to get some sort of ballpark estimate for what you're looking for. Otherwise, you'll have no way of verifying whether your answer is even close to being right. So again, we can manipulate the equation that we started with, I equals PRT. If we want to solve for R, we're going to divide both sides by PT. So R is equal to I over PT. And so here we have the R equals 200 over 1,000 times 4. And so you can see that's actually 200 over 4,000. We can do this without a calculator. We can just cancel out a couple of zeros top and bottom. You get 2 over 40, which is 1 over 20. And 1 over 20 is 5%, 0.05. So you can write the rate as a decimal. It's perfectly acceptable to say R is equal to 0.05. But more commonly, you might see it expressed as a percent. So you could also write it as 5%. Now, in this case, it's exactly 5%, but if it were a whole bunch of decimals and you were wondering, well, what do I round it to? There's actually no good hard and fast rules for how much to round this to. You might even see advertisements for investments for bonds where there are 4 or 5 decimal places. So, you can sort of use your judgment. If it's multiple choice, obviously you don't have to worry about how many decimal places to round it to. Certainly you want to have at least a couple of significant figures, 2 or 3 significant figures, I would say, meaning if it's like 5.23456%, I would say, go ahead and round it to 5.23. Don't just round it to 5. Let's take a look at one where the numbers, again, are not quite as friendly. We're looking for the rate. And let's imagine that we have an interest payment of $80. And we have principal of $500. And this time, the time is going to be 250 days. Okay, so again, let's see if we can do a ballpark estimate here. 80 over 500 is the same as 160 over 1,000, which is 16%. So this is a really high interest rate. But it gets even higher because 250 days is not a full year. So the interest rate is going to be significantly higher than 16%. 250 is a little bit more than 2/3 of a year. So it's probably going to be another half again. So instead of 16%, somewhere close to 24%. So again, that is just totally ballpark, but it gives us an idea of where we should be. And we'll use the formula that we used above, which is the rate is equal to the interest over principal times the time. So in this case, R is equal to 80 over 500, and 250 over 365, that's the time in years. So again, be very careful when you type all this into the calculator to make sure that you are actually calculating the denominator properly, putting it in brackets. This comes out to 0.2336. Now, I didn't actually have to round it in this case. It stops there. It is actually exactly 0.2336. And if we like, we can convert that into just 23.36%. So pretty close to that ballpark estimate I said of 24%. Okay, so what's the last thing we're going to worry about calculating? It's the time. All right, so let's try a time example. How do we calculate time? Let's again go back to our I equals PRT. And if we want to isolate T, we're going to divide both sides by PR. So I divided by PR. So let's come up with some numbers. Let's imagine that the interest earned is $100 and the principal is $1,000. Okay, so that's pretty straightforward. That's 10%. But let's say the interest rate is actually only 6%. Okay, so we're obviously going to need to do more than a year, but maybe less than 2 years here. Closer to 2 years than 1. All right, so let's go ahead and do the calculation. So the time is equal to I, 100, over principal, 1,000, times the rate, 0.06. Okay, so again, we punch it all into the calculator and we get 1.66 and repeating. So, is it acceptable to leave it as 1.666 repeating, or even round it at some point, 1.67 years? Typically, we don't express durations in terms of a decimal number of years. We express it in terms of years and days, or just days alone. So if you wanted, you could convert that to days just by multiplying by 365. Now, when we do that, we get 603.3, and the 3 again is repeating. So if I just round it to 0.3, I can put an approximate there, and I can say it's 603.3 days. But again, that's a little awkward. Once we get beyond a year, we sort of start to lose sense of how long we're talking about. If I told you, something was going to happen in 8,000 days, it doesn't really mean a lot. So a better way would be to write this as 1 year and a certain number of days. So you can just take 603.3 and subtract 365, and you would get 243.3 days. Now, I've given you an answer there with a fractional number of days, but in reality, that's not likely to be ever the case that you're going to worry about. The bank is not going to give you credit for having your money in there for part of a day. They want the money in there for the full day. So, in fact, if we wanted to really earn $100 and we were only getting 6%, and we invested $1,000, it actually wouldn't be enough to leave it in there for 1 year and 243 days. We'd have to leave it in there for the balance of that fractional part of the day. So in a lot of these calculations, you actually have to round up. And so you would have, instead of 1 year and 243.3 days, you'd have 1 year and 244 days. Okay, now there's one last thing, which is pretty straightforward, which is a capital A. When you see a capital A, what it stands for is an accumulated balance, or an accumulated amount. And all the accumulated amount means is that we take into account the principal that we invested, and then how much interest we earned. So it's kind of like all of our money, right? I mean, when you invest in Canada Savings Bonds, you maybe invest $1,000 or $10,000. You're earning interest, but at a certain point, the bond matures, which means that you actually go back to the bank and give them the certificate, if you have a paper certificate, and you get your original investment back. And so that total would be the accumulated amount. Now, we've got a formula for I, right? We started it off with that formula. So instead of P plus I can say it's P plus PRT. And now we have a P in both of those, so we can factor out that P and write this as P times 1 plus RT. Now, if you don't like this P times 1 plus RT, you can just go ahead and calculate the interest and add it to the principal. That's fine as well. So, final question here. Let's try and figure out the accumulated amount if we have a given principal of $10,000, let's say, and an interest rate of 5% and a time of 10 years. Okay, we can actually do this in our head, so let's just do it in our head before we actually write it all down and reach for a calculator. 10%, I always start with 10% when I'm estimating. 10% of 10,000 would be 1,000, so 5% would be half that, which would be $500. Over the course of 10 years, that'd be 10 times 500, so that'd be $5,000 in interest in total. And then our principal is $10,000, so we should end up with an accumulated amount of $15,000. And let's see if that's indeed what we get. So A is equal to P times 1 plus RT. So we have 10,000 for our principal, 1 plus 0.05, and then 10 for the time. And so that is 10,000. 0.05 times 10 is 0.5, plus 1 is 1.5. And so sure enough, we get $15,000. Okay, so there's maybe one or two little variations that I didn't really get to. And so if you have questions on those, feel free to send me an email or ask me about those.